as I said last week and even the previous week, the circus came to town over here. And we had Circus CERN. These folks, they came to town. And it turns out they haven't left. They're still here. And they came with all their show, their clowns. Okay. And so what are they up to? Well, these folks bring their slapstick comedy and so on. You know, they do some of this stuff. They work with the bosons, right? That's their slapstick stuff. And so, yeah, they brought a lot of questions and comments. And so today I got to answer all these things that they raised. Now, you know, when you heard one, you heard them all pretty much, right? But anyways, you see, they've got this slapstick comedy act, the bosons do. And you wonder, you know, what is a boson? Supposedly it's a particle. Okay, that's what they say it is. And it turns out that, we all understand what a particle is, a little ball, right? And so you say, okay, I understand that. It's a particle, it's a ball. That's what we're going to be moving around, etc. Turns out that, they do juggling, and they say they're doing these boson balls, right? And you say, okay, I understand that. That's straightforward. You know, that's what their act is all about. But it turns out that, when you look a little deeper, those are not balls. They're not particles. They're not corpuscles, not the traditional ones. So you say, well, hold it. What are they doing their slapstick with? And it turns out they're doing slapstick with concepts. They've got these things rolling around. They have fields and energies and who knows what. I mean, waves. And you say, well, is that the same thing as a particle? Is that a corpuscle that I'm staring at? And no, these are concepts. That's what they do their juggling with. Turns out that their jugglers then end up being actually mimes. They have absolutely nothing. That's what they're doing their slapstick with, nothing. And that's part of their show. That's, I guess, the funny part of their show. That you go in there to see a juggler, you end up seeing a mime just moving around. So yeah, it's a little bit of a problem to understand what the circus is about. It's a lot of fun. It's very funny, and I recommend that you watch it, right? But some people take it seriously. That's where we have a problem, when they take it seriously. Anyways, I had this troupe of clowns, Bozo and his group, and they came and visited me again. And again, once you heard one of them, you heard them all. So I don't need to analyze all these people because they all pretty much think the same way. Okay, so I'm going to answer one of them, and then another one who is not from the same circus. He's from a different circus. He's from the ether circus. So I'll address them separately. But they raise a lot of questions, a lot of comments. And I'm going to address those. And almost all of them are related to light. So these are the issues that I'm going to be discussing, in today's lecture. And I want you to keep those in mind throughout the lecture today, okay? The issue is, what is the architecture of light? Does light have an architecture? Is there an entity that underlies light? That's the only issue, okay? Now, I was going to talk a little bit about some other stuff, but I think we're going to have our hands full with this alone, based on the number of comments and questions that this individual asked. And so here we have it. Does light have a physical mediator? What do you think? I mean, do you think light is mediated by absolutely nothing? And if it's mediated by something, what is the mediator? Can we say that it's like the establishment holds, that it's transverse waves? Is that what mediates light? That's what they show you, right? And so that's one issue. The other one is it mediated by particles? The bosons. Well, we have a lot of bozos out there, but they say that it's some kind of corpuscle, and they call it the photon. They say, hey, this photon is what mediates light. Okay, a series of them, right? Okay, and then there's a third version, which is that all three of them. Okay, so we have the transverse wave, the particle, and the wave particle. Okay, so you tell me. Okay, which one would you choose? Is any of these valid? Can we use any of these to simulate light? That's the issue. That's the main issue today. And one of the problems I have with these clowns, with these bozos, is that they don't understand the question. They simply don't understand the question. They say, we do math. We want to tell you something about values, about the experiments they've done, and what they proved, what they verified, what they falsified. They talk about a lot of nonsense, and all we want to understand, we want to just get them to tell us what is the mediator of light. That's the only issue today. Okay? And you'll see where they hit on the corners, and they never hit in the center. That question. Okay, so the only issue, again, is what is the mediator of light? So here's the question, okay? What is the mediator of light? And here you have all these different versions. We have the one-way discrete particles. I put Alhazen, I think that's how you pronounce his name, Alhazen, I call him. Anyways, Alhazen, I think he was 11th century in the Arab world. And he's the one I credit with the particles, not the Greeks, because the Greeks thought that it was like Superman's vision, that the particles emanated from Superman's eyes and go through the wall. And Alhazen said, no, whatever you see, it's sending particles to your eyes. So that's the only reason I credit him. But it's just history, just so you know which one is which. Then we have the transverse wave. The waves were created by, what's his name, Robert Hooke in 1665, but it was Fresnel, French guy, who, beginning of the 19th century, he's the one who really came up with this notion of the transverse wave, trying to explain, with his picket fence, he tried to explain an experiment. Anyways, when he had proposed the transverse wave, Maxwell comes a little later, a few decades later, and he mathematizes this transverse wave. And that's what we have today, or at least what quantum has today. Then you have the one-way packets. I credit Penrose here. He's the only one I've seen that drew it in one of his books. Okay, so I use his wave packet, even though the notion already existed before him, right? Then we have the ether version, and also I think the flat earthers pretty much subscribe to this, that there's some kind of vortex out there. One of the proponents of this was Descartes, René Descartes, but I'm not sure if he's the first one to propose it. Anyways, there's these vortices, right? And exactly how that works with light, I have no idea, okay? And then you have my version, which I'm saying all these years what they've mistaken the transverse wave is with a rope-like mechanism or entity that torques. That's the mechanism. And so there you have the different versions that you can choose. If you have some other version, by the way, there's people also proposing that there is nothing underlying light. And so, if you have another proposal, hey, you're welcome to propose it. And before you can call any of these irrational, you have to define what you mean by irrational. We do define it in this site. We do rational science, so we better know what rational and irrational is or means. And we're saying that irrationality is when you reify a concept and begin to move it around. You turn it into an object. Again, like field or energy, right, wave. And also another criterion is failing to define the key words that make or break your theory. Those are sine qua non. You need to have definitions. And a lot of people think that when you define words, you're doing semantics. And that's another thing you should keep in mind today, okay? Because that's the official version, that when you attack them from a language point of view, that you're doing semantics and you're not doing math, you're not doing physics, etc., right? And yeah, what we're looking for is physical interpretations, mechanisms. For that, you had better have your language straight. That's the way we look at it here. And again, the third one there is the proposed mechanism is unimaginable. Then you have an irrational theory when nobody can imagine it. Like moving through the fourth dimension. Yeah, try that. Okay, so these are the things to keep in mind, okay, throughout the discussion today. It's going to be a dialogue because I'm going to present what they asked or what they commented on, how I'm going to answer that. Okay, so here let's start with the first one. What is light? And a fellow says, experiments demonstrate that light is what? An excitation of the field. The field, I guess a football field? Marijuana field? I don't know. And the fields carry energy and momentum. Carry energy and momentum. Sounds like he's got a semantic problem. When you talk about that, they say, oh, Bill, you're doing semantics. Well, it looks like the people who are doing semantics are the people who have these words, this language, this jargon, right? And he says, this is not semantics. It's measured in the lab. Well, how do you measure a field if a field is a concept? How do you carry energy? How do you carry momentum? There you see the field on the center almost. Turns into a particle because the vibration of field is what they call a particle. And a field is a concept. It's a bunch of numbers. That's all it is. Then you have energy over there on the right. And again, is that a physical entity? I mean, that's how they illustrate it, like, a little smog, a little smoke. Is that what energy looks like? I mean, what is energy? What is a field? It turns out that both of them are concepts. And yeah, you cannot carry concepts around. It's very difficult. I tried it. tried carrying love or intelligence. You can't. It's very difficult. And so these people, what they do is reify concepts. When you call that to their attention, they say, oh, Bill, you're doing semantics. Well, who started doing semantics? You or me? Okay. And so here we have the answer to this. Bill's claim that fields don't store energy or carry momentum is contradicted by what? By experiments? What do you mean? Well, see, he's saying that fields store energy. So he's now suggesting or insinuating that fields are physical objects that are storing another object called energy. So they're storing this thingy called energy. So I guess field is some kind of box, some kind of container, some kind of thing. So they treat field as an object. But then immediately he says electromagnetic fields are physical in the only sense science uses that word. And what is he talking about? Concepts. Predictive, measurable, with energy and momentum, budgets that match experiments. So you see, they treat the word field with this duality. They cover both bases. It's both an object and a concept. It's a thing and an abstraction. Okay, this is the problem. And you can see the definitions down at the bottom there. Field, what is it? Values at each point in space. That's what the definition, the formal definition of the word field is for the purposes of mathematical physics, which is not physics, by the way. Energy, the capacity, and it continues after that. And momentum, what is it? Quantity of motion. So far, all we have is numbers. And they're going to be storing energy in that field. What is energy in numbers? So they're storing numbers in numbers, right? And then they're going to carry this thing they call momentum. How they carry it, I don't know, because momentum is quantity of motion. So you can see the problem. It is a semantic problem, and it's the jargon that they use to express their physical interpretations. We got a problem because we're asking for an explanation of how this universe works, why it works the way it does. Please identify this fieldy thingy, this energy thingy, this wavy thingy, and it turns out they say, well, it's a bunch of numbers. When you say, how do you wave a bunch of numbers? Oh, you're doing semantic. It's a semantic attack. Okay. I think they're doing semantic. That me. Yeah, I'm asking the right questions. And here's, he clarifies, this fellow, he says, this clown says, energy isn't physical. I was saying that. Energy isn't physical. It says, what the experiments show, energy is not a thing you can scoop with a bucket, but it is as physical as momentum and charge. Well, yeah, I agree there, because momentum and charge are not physical either. Okay, so that's the problem. The problem is he thinks that field, energy, momentum, charge, all these words that he uses, are things, physical. we have a problem, because there you have it again. Energy is the capacity, and physical is what? That which has shape. That's the definition of physical. If you have a different definition of physical, hey, I'd like to hear it. I want you to defend your definition, because I'm going to attack it. Okay, so does energy have shape? And the question is no. Energy does not have shape. Momentum doesn't have shape, right? You can't talk about charge, because charge is a number. It's in coulombs, right? So we have all these semantic words, this jargon that these people introduce into science, and when you question it, they say, oh, Bill, you're doing semantics. It's a semantic attack. Yeah, because you got to get your language straight if you want the audience to understand you. And what you're asking for is an explanation. And they're not giving you an explanation. They're saying, look, we verified, we proved, we did an experiment, and it was falsified or not falsified or whatever. Falsified to whom? Who do you falsify this to? Okay? And so, give me a second here. Yeah, you can't, you have to attack the language, because that's where the problem is. The problem is language. And people don't understand that and say, I came here to do physics, not to do, language. I didn't come here to learn semantics or grammar, English or whatever. I came here to do physics. Well, you can't do physics without language. You need language, okay? So here you have another one. This is another bozo, but one from the establishment, more or less established establishment. His name is Nick Lucid, okay? Some of you have heard of him. And this is what he's going to tell you about what light is, okay? So let's hear it from him. Here it goes. So now you know. They're particle waves, wave particles, whatever that is. I mean, what is a particle wave? What is a wave particle? And so, yeah, we have a semantic problem, because we didn't understand. See, they already move on to the theory. Say, let me explain my theory to you. No, I don't want to hear your theory. I want to see the entity that mediates light. And they say it's a wave particle wave. It's a wave packet, What is that? Please draw it. That's the issue. And so, yeah, you have to start by illustrating the mediator of light. If you're going to say that light moves, hopefully only objects move. So if light is moving in any way, shape, or form, then it had better be an object. It had better have a mediator. So what mediator are we going to put? That's the issue. So that's what we're going to talk about today, the mediator, okay? And these people don't understand the question, because they say, well, it's a photon, blah, 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 and then they move on. They want to explain their theory, not illustrate the objects. And it turns out that the same Nick Lucid, what he tells us is that it's just a bunch of probabilities, really. Huh? Yeah, light is just probabilities. Okay, so let's get it right. Okay, so here it is. Listen to him, not to me. Okay, hear from the horse's mouth. Here it goes. Okay, so we have all these probabilities. That's what you're looking at, probabilities, which is what, statistics? What's that got to do with physics? What's it got to do with the mediator of light? And they say, look, it's all these particles, and the ones that arrive are, depends on the statistical nature of the particle. whatever that means. I want to know how the universe works, and they're talking about statistic, which is some mathematical concept that has nothing to do with the question I'm asking. And so it turns out that, if you're going to simulate light with particles, we have some problems. And one of the problems that I raised was the laser ranging experiment, run by really the United States and the Soviet Union both ran that. And that's that they put a laser, for those who believe that we went to the moon, they put a laser ranging, an array of mirrors essentially, right? And they shoot a laser from the Earth, and that way they can tell how far the moon is, and it's getting closer, getting farther away, that kind of thing, right? And so the question is, they shine this laser at this tiny 20 by 50 centimeter, 20 by 50, right, array. Okay, so tiny thing, right? So big, that's it, on the moon. And so they shine the laser at it. But imagine if you have to shine particles. You're throwing little balls now, right? So you're throwing little balls because that's what light is according to these people. But it turns out the moon moved. And it moves 1 kilometer per second. So when you're pointing your laser directly at the array, well, that can't be so, because it takes more than 1 second for light to reach the array and another second for it to come back. So it takes 2 seconds. It's a little more than 2 seconds, really, slightly more. So it goes and comes back, and it turns out when these people focus, it stays there. The light is fixed to the laser, to the array, to the lunar ranger, but the moon moved. So how come we can focus directly on there? That's the question. And so this is the question I raised, and so he tried to answer this, and he says, Bill, this is me. I said, lunar laser ranging doesn't work because you'd have to aim where the mirror will be. And it turns out he doesn't really put the question. He doesn't understand what the question is. So I have to put the question now one more time in red, in that red square. The question is that you can't explain this with particles. That's the issue. It's not that I'm falsifying the lunar ranging or all these nonsense that these people raise. No, you cannot explain lunar ranging with particles. That's the issue. That's the only issue. And she says, you do not need to pinpoint aiming at a tiny flat mirror. You illuminate the array. Yeah, but the array is only 20 by 50. He doesn't understand that. It's a very small array. And the issue here is that the array moved 1 kilometer away from where they focused. And you're talking about 2 kilometers by the time they received the light back here on Earth. So the array is not where you pointed to before you sent, the particles. So the issue here is that you cannot explain the lunar ranging experiment with particles, with discrete particles. Okay, by the time they arrive there, the moon is no longer there. That's the issue. And he doesn't understand that. So he raises issue, that you focus on the whole array. Yeah, you can't focus on the whole array because you're focusing on the array and it turns out the array is no longer there. Now it's over there, 1 kilometer away. So how do you focus? And that's not what happens. In fact, they do focus, meaning that light cannot be made of particles. That's how simple it is. Okay, you cannot focus. If you focus, which they do, then light cannot be made of particles. That's the issue. It would take 1 second for particles to reach there, another second to come to your eye. That's not what they see. They see instantaneously. That's how they see it there. And the only way, again, that you can do that is if every atom from the array is connected to every atom in the laser, or your eye, for that matter. Every atom's already connected. The moon can go anywhere it wants now because light will go along, the electromagnetic ropes, which we propose as mediators for light. Okay, so here I explained to him a little bit, saying that the retroreflector is 50 times 20 centimeters wide, right? And so in terms of the light going and coming and going, we have, the ranger is not there when you look at it. In fact, in terms of the size of the reflector, the fact that the moon moved, 1 kilometer is 2,000 times as long as the little array. So you cannot focus on the array like he's saying, because it ain't there anymore. That's the issue. It says the moon is 380,000 kilometers away. It takes photons traveling at 300,000 kilometers per second, a little over a second to reach the moon, let alone coming back, right? And this means that the discrete photons coming off the laser and traveling one way will reach the reflector's original location, but the reflector is now 1 kilometer away. In other words, the idiots at NASA would need to point the focus their laser where the reflector will be in 1 second. Okay, so they have to focus in advance to where the array is not. That's the issue, and that's not what they do. In fact, they focus directly on the array, meaning that if they can do that instantaneously, because as soon as they move the laser, right, and follow the array, it's because if it were particles, it would describe a curve in space. That's what would happen. That's not what's happening. What they see is directly. They see the array directly. Like I'm staring at you right now. If you move, and light if you're I don't know, 2 light seconds away, you're on the moon, right? And I want to look at you, right? Well, I got to look at where you will be, not where you are, because by the time the photons go and come back, you're not there anymore. You're over there. That's the issue. But he doesn't understand that. I think it's something straightforward. Okay, so how does he explain this stuff? Well, when they talk about light, they talk about geodesics. And so he says, light follows 0 geodesics of the space-time metric. Call it the road curves, if you like. Yeah, the issue here is that, he says, he's essentially saying that the discrete photons follow geodesics, which is like saying that you follow your run. Because geodesics is a trajectory. It's the motion of something. And so they're saying it's following the motion. It's like, when I run, I follow my jog, my run, the run that's in front of me. I'm following the run. That's what he's saying. And that's the kind of language these mathematicians use. And so, yeah, we have a problem. You don't follow your run. Okay, but that's what they're saying. And here's a little illustration of what they're talking about. They're talking about this, 2 elephants. And these 2 elephants are moving along geodesics. And they're going to bang their heads, wherever they meet. And this is what they call a geodesic. So the geodesic, what is it? It's a trajectory. It's an itinerary of the 2 elephants. So if you have the Earth there, you have the 2 elephants. And they're going to run along and follow, as they say, the geodesics. Why would they follow the geodesics? And they say, well, they do. I mean, why can't these 2 elephants go in parallel, completely in parallel, and not curve around? And again, we don't have an answer. They just say, it is so. So they have no explanations for these types of phenomena. They just say, it is so. We measured it. Okay, tell me why. What's the cause? And so when you raise issues like that, they say, oh, Bill, you're doing semantics. So I say, gravitational lensing bends light. Are the idiots of math bending the road or the car? Because, when they say they bend light, we're talking about the mediator of light and not the fact that light is following a curved road, following the geodesic, right? So is light following a curved road, or is light deflecting from its rectilinear itinerary? Which is it? And so you say, oh, you're doing semantics because physics is measured. No, you got to explain after you measure, and they don't explain. They just say it is so. And again, measuring is what these idiots do. In science, we do what he calls semantics. So that's the difference between science and what these people do. So we have a problem with their language. Very important, and we still don't understand what the mediator of light is according to their version. We want to see what their version is, and please explain whatever phenomena with your version. I don't care if you propose particles or waves or wave packets. Propose whatever you want. but then explain with that thing that you proposed. But see, they switch around. They say, well, here I use the particle, and over there I'm going to use the wave. And sometimes I use the wave packet, what, it's like, what is light? Is it a wave or is it a particle? And if it's a wave, what are you talking about? If it's a particle, what are you talking about? Are you talking about what is a particle? A vibration of a field, a local vibration of a field. And that means that, again, we're talking about numbers. So we're talking vibration of numbers here. In the case of wave, it's also vibration of numbers because it's made of two fields, which are made out of vectors. So we're talking about just vibrations of numbers. Is that what light is? A probabilistic thing related to vibrations of numbers? I mean, what are we understanding with all this? And here we have good old Lucid, again, Nick Lucid, and he's going to tell us something about the fact that, light travels at different speeds in different media. And I guess, again, he's going to do this with particles, waves, I don't know. Let's see which one he uses. And here he goes. Listen to him. So light slows down, perhaps, maybe, because we don't know that. According to him, we don't know that. Second, where he's, I guess, illustrating a one-way mechanisms, meaning what's he doing? He's either using the wave or the particle. So whichever one we use, he's saying it slows down inside a more dense medium. But he doesn't explain why. Why does it slow down? He says it just does. It's a statistical issue. And here he explains a little more. I hope you understand it. I don't. So here goes. Listen to him, okay? So we have now many paths for light, and I guess they take an average, a probability, a statistical issue, and that's how they explain it. Explain with quotation. They haven't explained anything. What they're saying is, look, mathematically, that's what we get. It's a probability issue. In fact, they invoke Fermat's principle, French guy who came up with the least time for the trajectory of light. And here, listen to him. Again, this is Nick Lucid presenting Fermat's principle. Okay, listen to him. So what is it? We have probabilities on top of probabilities on top of probabilities. It's all probability. It's probable. Maybe. Perhaps. That's his side. Here we have another fellow, another bozo. He's from Fermilab. The name is Don Lincoln. He's going to tell you a different story, okay? He's going to tell you, he's got the right answer for white light curves. And it might have something to do with the speed of light, the fact that it changes speed from medium to medium, but he's going to give you a little more. He's going to tell you exactly why, light goes slower. Okay, listen to him. Here goes.
We can see what light does when it enters glass or water or any transparent medium. It bends. And the reason that it bends is because the epsilon in glass is bigger than in air. You start out with glass with no electric field in it. The glass has charges in it, but they're arranged in a random way. But when you send light in, you impose an electric field on it. That field makes the charges move around which sets up a counterbalancing electric field from the charges. The result is that the electric field in the glass is lower than it is in air because of how the electric field from the glass is in the opposite direction. And this is the reason that the perpendicular electric field is lower in glass. And that, my friends, is why light bends when it goes from air to glass.
So now you know, okay? That's why light is slower in glass. It's got to do with all these fields. He explained it. What is a field? A bunch of numbers. I mean, look it up. Don't take my word for it. It's a value at each point in space. So he's saying because of all these values, light comes out slower. What are we going to say? So again, all these people are just talking about numbers. They don't explain anything. It's just a description based on mathematical abstractions, which they have converted into physical objects. You can't use the word field, the word wave, because they're not to explain or simulate light because they're not physical objects. They're just a bunch of numbers. You can't use the word energy, a bunch of numbers. They're all numbers. So these are not explanations, and of course they don't. I guess that's why Richard Feynman said, we have no clue. We have abandoned the attempt to try to explain how the universe works. And yeah, they never will. And the only issue is they gotta let go of the particle hypothesis. There are no such things as discrete particles because you cannot explain a single phenomenon of nature, invisible, the invisible, intangible part, the mediators. You cannot explain them with particles, with discrete particles. Everything had better be connected in the universe. Otherwise, you cannot explain. Otherwise, you got to introduce action at a distance, entanglement, gluons, that stretch somehow. Action at a distance, which is black magic. So the entire universe is physically connected somehow. Okay, you can't do it the quantum way. What does quantum mean? Discrete quantity. And again, we're not talking about quantities, which is what math is all about, which is what quantum was all about from the start. So they try to do it mathematically, and that's where it all failed. Okay, now another question is, why does light, when it exits the glass, okay, this guy says it's the field that, electric field, it's modified so it goes slower outwards. Great, let's concede that. Why does it go faster again? Why does light go faster again once it goes back to the original medium? You have a little bit of glass in the middle of space, right? In space, they all agree light travels at 300,000 kilometers per second. No problem. Okay, it goes through the glass, right? Glass is, we used 1.45. Most people use 1.5. It doesn't matter. 1.5 times is the refractive index. That means you would have to divide the speed of light by 1.5 and you would get your 200,000 kilometers per second, which is what it travels allegedly, according to these people, through the glass. But now it goes to the other side of the glass. So it should go back to 300,000, I hope, right? Because now we're back into space, right? And so the question is, why, after slowing down through the glass, now it picks up speed instantaneously? As soon as it passes that last barrier of atoms of the glass, of the molecules of the glass, suddenly it goes back to 300,000. Cranks up the speed, goes back to 300,000. How does it do it? What's the mechanism? And so they don't have a mechanism, but so here's this bozo from the circus, right? And he says the following. Says, speeding back up is simply the wave obeying the vacuum dispersion relation, blah, 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 right? Once it exits the medium. Again, it's a description. These people don't even understand the question. What do you mean the vacuum dispersion relation? He's talking about math. He's saying we describe it and it turns out that, it goes back to 300,000. That's all he said. He's not giving you a why, a physical cause. Okay, he just said the vacuum dispersion relation. Great. And but he uses the wave. And so is this what he's using? Because he says the wave obeying, right? And so the wave is that thingy that you see there. Looks like a bunch of arrows. But it turns out, you're staring at numbers being represented by arrows. All those are numbers. vectors, fields, the wave, all that you're staring at are numbers. And so they're not talking about some physical entity. They're just saying, look, we've measured and this is what we came up with. Okay? And so, we have a problem because they have a semantic problem. And second, they don't understand the question. They don't understand the question they have to answer. How will they ever discover what we're looking for if they don't even understand the question? They keep giving you answers that have nothing to do with the question you ask. I want to know what physical entity underlies light. Whatever you use, I don't care, whatever you use with that explained light. So whatever you introduce, right? You introduce particles, no problem. Now explain light. And then they say, well, we measured. I don't care if you measured and that you have the equation. We don't give a damn about that. Okay? This is the issue. Okay, so, the speed of light is 300,000 kilometers per second. It's a constant, right? According to the equation, c equals frequency times wavelength. That means when frequency goes up, wavelength must go down and vice versa in order for little c to remain a constant. Okay, I don't know if I need to explain that again. You have little c, 300,000 kilometers per second, equal to frequency times wavelength. Means frequency and wavelength are inversely proportional. If frequency goes up, wavelength must go down for c to remain constant, and vice versa. When wavelength goes up, frequency must go down for little c to remain constant. And the question, here's the million-dollar question. Why don't we raise both the frequency and the wavelength so they're both higher, and we travel at not only faster than light, we can travel at infinite speeds, at any speed you want, because we raise both the frequency and the wavelength. And so here's his answer to this question. He says, frequency and wavelength are tied by the dispersion relation. Again, he talks about relation, like saying that's what holds these two parameters, these two variables, that's what holds them constant or at a certain level, because they're governed by the dispersion relation. He thinks he's answered the question. I want to know physically what's happening. Why? Why can I not raise both the frequency and the wavelength of a wave, right? Because that's what we're talking about if we're talking about waves, right? Why can't I increase both of them? If we're talking about particles, whichever way you can imagine frequency and wavelength in terms of particles, well, why can't I put more particles or spread them out or whatever and make light go faster? That's the only issue. And then he comes up with this other nonsense. Group and phase velocities can exceed c in dispersive media without information transfer. Well, I don't know what... Science doesn't deal with the word information. Okay, it's garbage that mathematicians introduced there. We don't use the word information because information is an abstract concept. We don't use it in physics. We have no use for information. And we can't transfer concepts, so we don't transfer information. Any idiot who uses that language should be kicked out of science. Okay, that's the first thing. The other one is, group and phase velocities. Okay, they can exceed little c, no problem. Can we increase your group and phase velocities billions of times both, so that again the speed of light in dispersive media or whatever within the wave or whatever you want to propose, can we make light travel billions and trillions of times faster than light? That's the only issue. So don't tell me it can go a little faster in a phase velocity or whatever. Tell me if they can travel at gazillions of times the speed of light. Because if we can raise the frequency and the wavelength, right, gazillions of times, then we should be able to travel instantaneously anywhere in the universe. Why can't we do that? What's preventing us from doing that physically? That's the question. Again, we got to go back to the entity. What mediator does light have? What is the physical mediator of light? And hopefully if something is moving, it had better have a mediator. And so this is the issue. Okay, we have another issue with light, because when you shine light like through a lens and to a mirror, it turns out that the mirror sends the light right back to the lens and back to your source instantaneously. Why? Because it's retracing its exact path. Let me repeat that. Light retraces its exact path. When it goes, it also comes along the same line. How can you do that with particles? The moon, right? You send particles to the moon, but the moon's no longer there. So if it's going to hit the mirror, it better, describe a curve in space, and then another curve to come back to you, right? And, here you have a little flashlight or whatever, you point it at the lens, and from there to a mirror, why do you get the reflection right back instantaneously? I mean, everything in the universe moved. We moved with respect to Jupiter, the Earth moves around the sun, etc., etc. And it turns out that light always retraces its exact path. How do you do that with particles? How do you do it with any one-way mechanism that you propose? Any one-way, well, yeah, it's a mechanism, but I mean, we're talking about what the mediator of light is. Can you do it with particles? Can you do it with waves? Or one way? By the time they go, will they retrace the same path that they went? How do you do that? How do you explain that with particles or waves? And so this is the issue, and they don't understand the question. And here's his answer to that question. He says, Maxwell's equations are time reversally symmetric. Yeah, we know this. Don't. Is there an echo in here? We know that's the question. Why is it symmetric? He said, Lorentz reciprocity theorem guarantees ray reversibility. That's his answer. Okay, so we get a mathematical answer. Oh, we proved it. Yeah, tell me about it. That wasn't the question. The question is, can you explain it? And of course he can't, because for that you would need to know what the mediator of light is. And if you do it with particles, you cannot explain it. And if you do it with waves, you cannot explain it. So you have to get rid of the wave and particle hypothesis. Waves first, because they're not physical objects. Particles, because they're not talking about particles. They're talking about numbers. And so with numbers, yeah, we can describe it mathematically, but explain it physically, I don't think so, right? And if you have the particles, yeah, this is what you would see through space. Imagine an atom within the sun, okay? That atom is pumping, right? It's you got this quantum jump, right? So the atom is going from energy level to energy level, back and forth, right? In different places around the nucleus, right? One atom, right? And that's when it's creating light. It creates light when it jumps from one energy level to another. That's the official version, okay? But this atom is spinning. The sun is spinning at great speeds and sending all these photons that come out of the sun outwards. So this is what the sun would be describing, like a sprinkler system, right? Nothing would travel straight. Everything would travel in curves around, to your eyes. And that's not what we see. We see direct light, coming to us. It's not curving at all. The photons are not flowing all around space like a water sprinkler. And so, yeah, we have a problem with their version with particles. You can't do this. You can't simulate light with particles. That's the question. That's the issue. Okay, then we had the issue of why light goes through walls. And so this is what he answers. And it says, X-rays pass through walls. Well, it says, I say that. X-rays pass through walls. Why not visible light? He says, refractive index comes from electronic hand structure and resonances. Yeah, refractive index is a mathematical concept. That's not an explanation. It's just a description. Visible light is strongly absorbed, scattered. Yeah, tell me about it. X-rays couple weakly and have longer attenuation lengths. All these answers, coefficients and constants explain why. Explain, he says, Coefficients and constants explain which wavelengths penetrate which materials. So again, he thinks he's explained. He's only giving us mathematical descriptions. He doesn't understand the question. He really doesn't understand the question. And all they do, all these folks, right, all these clowns, what they do is they simply regurgitate what the establishment fed them. Whether in school, high school, college, they just regurgitate the same thing and pass it on. No, you have to explain. And what the mathematicians cannot do is explain. We have the wrong people doing explanations, and that's what people want to understand out there. People say, please explain. I want an explanation of gravity. I want an explanation of light. of the atom, and they do not explain. They give you a description, a mathematical description, which they turn into an explanation. Say, there, I explained it. I didn't understand anything. Well, you got to take math to understand it. Why do I have to take math to understand why, for example, pencil falls to the floor. Here's a pencil, gravity. Why do I need to take math to understand the mechanism of what's causing that? And this is the issue. These people don't understand the question. So they're not answering the question they're supposed to answer. One. Second, they tell you they can't answer. Those people who just figured it out, they say, well, we can't answer. These people are telling you, oh, yeah, we can explain it. Oh, you can? Yeah. Here's the numbers. Here's the experiment. Here's the observation. Here's the verification, the falsification, all that nonsense that they come up with. Okay, he challenges the rope, and he says, the rope hypothesis makes no quantitative predictions. Absolutely. Thank you. Yeah. So please don't request them. Okay. We don't do astrology, palm reading, witchcraft, none of those things. Okay. We don't do black magic here. We don't do predictions. Okay. Predictions belong to religion or to astrology or whatever. No, what we do, we explain. Okay. That's what science is about. That's what physics is about. Explanations and only explanations. Nothing related to math has anything to do with physics. You can do your math and describe all you want over there. When you come to the physics class, come to the physics conference, we want an explanation, a physical interpretation of how you think the universe runs. For that, you need to figure out what the invisible, intangible mediators are for light and for gravity. Otherwise, you can't explain it. Can we go to the lab and verify, falsify, blah, blah, blah? No, you can't. You're talking about invisible, intangible. Invisible, intangible, invisible, intangible mediators. What is lab? See, touch. That's what a lab is, see, touch. And we're saying it's invisible and intangible. I mean, here's the pencil again. Do you see anything here? Can you touch anything here other than the air, right? No, of course not. I'm running my hand right through the objects that either are pushing or pulling on this pencil. It's really pulling, but assuming you have a different theory, no problem. But then you have to identify the objects, and hopefully they're invisible and intangible. Don't tell me we're going to go to the lab to find out, what's pushing this. No, this is not an issue of going to the lab or verifying or falsifying. This is an issue of please explain what's causing this to fall to the ground. And for that, I need no math. I need whatever object you propose had better be invisible and intangible. Otherwise, you're not imitating what Mother Nature has out there, because what she has out there is invisible and intangible. So don't ask me to go to the lab. Don't tell me, let's do an observation, let's do a verification, let's do a falsification. No. The only way you're going to falsify is declaring that this is an irrational explanation. Then you can falsify it. Falsify it, meaning you convince someone. Otherwise, you just need to explain what's pushing or pulling on this pencil. That's it. There's no other possibility. And it better be, whatever you propose, better be invisible and intangible. And here's my version of what the rope does. We explain. That's what the rope version is all about. The rope hypothesis makes no quantitative prediction. Absolutely. We don't make predictions. If we are to talk about how the electromagnetic rope relates to quantities, the electromagnetic rope explains these numbers. No, we're going to explain the numbers, right? Not the mechanism. We just want to explain the numbers. Why light is so fast? Light travels at 300,000 kilometers per second. Why is it so fast? Well, the rope can explain that because torsion, a torsion wave, a 3D torsion wave, right? If we want to call a torsion a wave, is the fastest thing imaginable. There's nothing faster than a torsion. Nothing. Because it's already connected at the other side of the universe. That's why. So you don't have to travel to the other side of the universe to find out. Torsion is the fastest thing that anyone can imagine. Okay? And I always suggest people put a rope between two walls or between two things hanging onto them, make it very tight, and put two clothespins at each end. As soon as you move one clothespin, the other one moves instantaneously. Why? Because it's already connected at the other end. That's why. Rope is already extended. Okay, and it's invisible, intangible. You can pass your hand right through it because that's what you have to propose. Whatever you propose has to be invisible and intangible. Otherwise, you're not imitating Mother Nature. Then the speed of light is constant. Why? Well, the rope obviously can explain that very easily. If you increase the frequency, meaning the number of links, each link has to be smaller. And if the links are longer, then you have fewer links. Very simple, and that's the difference, and that's what the frequency and wavelength stand for in that equation. That is the equation of a rope. There's no other thing that can imitate that equation. Maxwell came up with that equation, by the way. The speed of light is independent of the movement of the waves of the source. Why? Because the atoms simply glide through the rope, and as they do, the rope feeds into the atom because the rope, each thread makes up the atom itself. So it's not like it's connected separately. The ropes become the atom. Okay, each one thread goes through the center and the other one goes around it. So you're gliding through the rope, and because of that, you're not increasing or decreasing the frequency of the rope itself. Okay, so that's the only thing that can more or less that circumstance, that situation is what explains why the speed of light is not added to the speed of the source. Okay, any atom falls to Earth with the same acceleration from a given distance. At a given distance, you have all these ropes from the Earth, right? This is gravity, right? Converging upon that atom. So it doesn't matter what the atom belongs to, what entity could belong to an astronaut, to a feather, or to an elephant. It won't matter. If it's a hydrogen atom at a given distance, you have the same number of ropes from the Earth converging upon that atom at a given distance. Period. That's what it is. That's what weight. Weight is location dependent, location specific. Okay? It's a static concept. Weight, as soon as you move a teensy-weensy inch, or even less, a centimeter, a millimeter, whatever you move, you've already changed your weight. Why? Because suddenly all the number of ropes, independent ropes that are tugging you from the Earth has changed. That's what it is. And so, weight, these people don't understand. They say that weight, it changes with time. It changes with for example, if the Earth, if the sun were to disappear, the Earth would take 8 minutes to learn about it. No, if the sun were to disappear, there would be no ropes from the sun to the Earth. If we could make that magic trick and make the sun disappear, the Earth would fly away instantaneously because it's being tugged by the sun. No sun, no tug, instantly. It's like you're hanging from the mountain from a rope. I cut the rope. It doesn't take 1 second for you to receive the message, the information. No, you fall instantaneously, okay, because that's what was holding you. The tug on that rope. Okay, it explains the underlying cause of the principle of equivalence. That's a long story, but essentially we're saying that Newton's equation is equal to, a gravitational equation is equal to his second law, force equals mass times acceleration. Okay, so we have an explanation for all these numerical, these mathematical concepts, okay? We're not interested in answering that. We're just saying we have no quarrel with the equations, okay? We have no quarrel with the equation. We're just giving a physical interpretation to these equations, and we have, I guess, a physical interpretation for them that doesn't rely on particles or waves. What we need to get rid of, what we need to kill finally is the wave and the particle proposals. That's what dies. Okay, meaning all of quantum dies and all of general relativity, because relativity is based on the particle nature of light and the wave nature of light. They're talking about waves, gravitational waves, light waves curving around the sun, etc. So they're simulating everything with waves and with particles also. So both theories die a sudden death, and together with string theory, which is trying to merge the two. Okay. So we have a problem with the particle hypothesis essentially, and the wave also irrelevant. In fact, they don't use the wave as often enough. They usually use the particle. And what is a wave made of? Probably particles, right? Okay, and finally he says, Bill attempts to falsify observations. No, we're not forgers. Yeah, we don't try to falsify anything in science. It's the irrational mind that talks about observations and about falsifying. In science, we do not falsify anything. Scientists are neither forgers nor counterfeiters. It is the mathematicians who spend their time falsifying theories to match their equations and selling their irrational theories as fact to the general public. One thing we don't do is talk about facts, proof, evidence, knowledge, experiments. No experiment's going to tell us the nature of light because it's invisible and intangible. So whatever you do had better be invisible and intangible. So don't ask me to go to the lab to run some experiment and obtain some evidence to present at the conference to be falsified by some other nut in there, right? No, it doesn't work that way. This is what they call armchair physics, which is the real, true, genuine physics. You sit back, you get a beer, and you visualize. You try to imagine how Mother Nature runs this universe. And we're not going to do it by going to the lab and saying, I'm going to run an experiment. What are you going to run an experiment for? What are you trying to see? Are you trying to see the invisible? Are you trying to touch the untouchable? I mean, what are these people trying to do? This is so incredible. Here we are, so many centuries later, and these people are still doing experiments. What for? Science needs to know how we run this universe. That's all science is about. And that's all it ever was, but they never figured it out because they never defined science or physics. They have these irrational definitions of the word science, of the word physics, and that's why we ended up in the big mess that we have today.